Hey everyone, so in this video we're going to look at how to make a catapult and how to have that catapult fling a projectile across the screen. Now as you probably notice, I already have the objects that will make up the catapult at the bottom here. I figured it'd make the video kind of long if you had to sit around and watch me make the 3D objects. As far as how I made them, they just come from the game object menu, 3D objects, and I use things like cube and sphere and then just scale them in various directions. And then also I use Pro Builder for making the arch. If you want to see that, let me know. I can always make another video. I just really wanted to focus on how the catapult works and how the projectile works. So let's go ahead and assemble the catapult. Most of these will be in the proper position because when I had the catapult in the screen, I just dragged and dropped them into the asset area, which, by the way, turned them into what's known as prefabs. So when I put them back into the game area, the scene, they're going to retain that position. So let's get started. So let's put the base in place. Let's put the arm in place. And now let's add the cubes to the top. Let's add the projectile. Let's add the cylinder. And then let's add the arches. And again, this went really fast because these were the locations that they were in the scene when I turned them into prefabs. Because if you click on the individual prefabs, you see they retain the transform component. So they retain the position. So there is our catapult. Now the arches, as well as the base, is to secure the catapult because we want the arm to stay in a certain place. It needs a little room to move, but we want it to be able to rotate within a very limited area, like a real catapult arm. So there's multiple ways to control a projectile. Sometimes a projectile has its own propulsion. In this case, that's not how it works. It's basically impact. The arm is impacting. It's pushing the projectile. So this won't actually have any coding associated with it. It'll have a few components, but there won't be a script associated with it because it's getting its momentum from the arm. So how does this work? Well, for the arm, if we wanted to just say rapidly rotate this arm like a catapult, here's the problem. This rotates in the middle. You don't want it to rotate in the middle of the arm. You want it to rotate at the base. So what you can do is you can make this a child to this, and then you rotate this object, and then the arm will rotate around it. There's other ways you can do it. You can use a hinge and things like that. I'm keeping it super simple. So this is going to be the parent to this, and so when you do something to this, this inherits it. So how do we do that? You simply drag and drop the arm onto the cylinder. Because the cylinder is the parent and the arm is the child, you can see how it's indented now. Likewise, we also want these to rotate around, so these need to also be children. So we will take the cube 1 and put it on the cylinder, and cube 2 will also be on the cylinder. So now this, and this are all children to this. So again, when this gets rotated, they will rotate around it. Now we're just going to tweak a few of these things. Like we want this sphere to actually be sitting on the arm. And we can also tweak these. These were never quite the right size. So blue, that is the Z axis. So that means this needs to be increased in size a bit. So let's make this like 0.5. Let's push this down a little bit. I'm just looking at the edge here, just kind of eyeballing it. I guess that's about right. We could always shrink it a little bit. So the other cube should be identical, so it's also 0.5 then. And we'll also line it up. Okay, so now this, and this are all children to that, and we're almost ready to apply the coding. I just want to explain a couple things though. So for a collision to occur, so for an object to be able to touch another object and not just pass through it, you need to have what's known as a collider. And there's different types of colliders. Like this has a box collider because this is a rectangular shape, so it has a box collider to form fit to its shape. This is a sphere, so it has a sphere collider to fit to its shape, so on and so forth. Okay, so the collider is what allows for, as the name would suggest, collision. So objects can touch each other. You can set them to be triggers, though. On a side note, if you choose trigger, then they can pass through each other. We don't want that. We want a solid collision for this tutorial. The other part, the other component that needs to be present for this to work are what's known as rigid bodies. Rigid bodies allow for the application of physics. So if you notice, our sphere has a rigid body. If you want, I'll just remove this. The way that you would add it is you just have your sphere selected. You click on Add Component, Physics, and then Rigid Body. We do want gravity to be used because we want this to arch out, so we want it to go up and then be brought down. So we do want gravity to be used, which is by default. Now mass, we'll do a few tests with this, but the lighter this object is, the farther it'll fly, which kind of makes sense because you think about how much force or work is being done. And so the relative weight makes a difference, or should I say the relative mass, excuse me, makes a difference. So for instance, if we have this at 0.1, we're going to want this to be much higher. So we've got this all the way at 10. So this, however, does not get its own rigid body because we want it to inherit the motion from this. Okay, so this will rotate. It has much more mass than that, so it should be able to fling it. We made this, this, and this a child to that, so this will now control those insofar as if it moves or scales. These secure it in place, so that should basically give us what we need. And just like the sphere, this also has a rigid body. I could remove it and apply it, but again, we already reviewed that, how to do that. Okay, so the final thing is the coding, and this is super simple. This is going to take maybe 3 or 4 minutes. So right-click, create C#, and we'll call this fling. You can call it whatever you want, really doesn't matter in this particular case. And what we're going to do is the cylinder is going to have the script attached to it. So we want this to happen as soon as the scene starts. So as soon as the scene is instantiated and the object is instantiated, we want this to happen. So we're going to do this in the start section. What's in start only happens once. So we said that we want to modify a component. What component was it? We said it was the rigid body component. And so the code just writes out just like that. Get component, rigid body. We said, actually, I don't think we said expressly, but we're going to use what's known as angular velocity. So which vector are we going to apply this to? We're going to apply this to z, and if I recall correctly, it has to be a negative. So basically, for the very first frame that this object exists, it's going to receive an angular velocity of -5. So let's see if that works right. And it did. You now have a very rudimentary catapult. Just going to move the camera a bit so it's not quite so close, and we can get a better view of what's going on. Now, a couple things. we mentioned the mass of the sphere. So watch what happens if I change this to 0.01. Okay, so it basically was right there where it dropped off the screen. Now let's bump this up to 1. See? Didn't go nearly as far as way over here rather than way out here. So if you're trying to control how far it goes, just like in real life, you're changing the mass. Now, maybe we want this to stop at a certain distance. So maybe we want it to stop when it's vertical. We'd have to do a little guesswork, but what we can do is you can use IE numerator to get it to stop. I suppose you could put like a another object on top of the arches so it hits it and stops. You certainly could do that. Or you can just remove the angular velocity. So outside of start, outside of update, let's do IE numerator. And let's call this stop arm. The name itself really doesn't matter in this case. It's for the benefit of you, the designer, to know what it's going to do. It's going to stop the arm of the catapult. Yield, return, new, wait 4 seconds. Let's do like 0.3f. Okay, so I usually like to explain everything, but for the purposes of this demonstration, just know that you have to type this because what you really care about is this. You're saying wait a certain amount of time measured in seconds. It's going to be 0.3 seconds, and as is typical with Unity, if you use a decimal, you typically have to drop that letter F in there so it doesn't confuse it. So that's all this is really saying. This is saying wait a period of time and then do something. Okay, well, what do we want it to do? We want it to now apply 0 velocity. So the velocity is being set to 0. So regardless of how fast or slow it's going, this should bring it to an absolute 0. I've noticed that sometimes when you do this, the object may drift a tiny bit. I haven't quite cracked why, but if you're using this particular method, you may see things drift a tiny bit. But again, this one is really just the broad strokes, this demonstration. So this will not ever execute on its own. You have to tell Unity because you designed this yourself. This is one of your own creations. So you have to tell Unity when you want this to be used. So start coroutine, stop arm, including the parentheses. So now you're saying on the first frame, apply this angular velocity and then start this coroutine. Unity looks at this coroutine and says, okay, I am to wait 1/3 of a second, or 3/10 of a second, and then do this. Save that. And now we run it. So it stops there and then drops back down. Because again, gravity's being applied. And then you can just mess around with that. You could have it say faster velocity and maybe be slightly longer before it stops. And actually this time it's like wedged under here, so that's why it's not moving. So okay, so I think that should about do it. Again, it's not meant to be high tech. This is just meant to be a basic introduction to a certain type of way of controlling a projectile. And in this case, the projectile is moving based on impact from another object. So it doesn't have its own source of propulsion. It's receiving the velocity. It's receiving that energy through collision. So I think that should do it for this video. If you have any questions, just let me know, and I hope this was helpful.